Okay, today we're going to talk about isosceles triangles, and we're looking at some of the properties that have to do with isosceles triangles. So we're on notes 4.7, so look for this page in your notes packet. We've already touched a little bit on isosceles triangles, so we just want to get familiar with some of the vocab. So first of all, I'm thinking about the sides. And on an isosceles triangle, it will have two sides that are congruent. And usually they're marked. These are called the legs, the two sides that are congruent, and they'll be marked with one slash or two slashes. Okay? Those are the congruent sides called the legs. The non-congruent side, or the third side, is called the base. So congruent sides are referred to as the legs. The third side is called the base. The angles opposite the congruent legs are called or referred to as the base angles. So that would be that angle and that angle, opposite the congruent legs. The angle that is opposite the base, the non-congruent side, is called the vertex angle. So that's this angle up here. In this case, it's at the top. So just some familiarity when you're talking about the terms that have to do with isosceles triangles. Now, the base angle theorem, pretty popular in geometry, says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So this says if you have two sides of a triangle that are congruent, if you have this, then you know you have the angles opposite those two sides will be congruent. Now, the converse of the base angle theorem says that if two angles of a triangle are congruent, then the sides opposite them. So here we're given the fact that we have two angles congruent. So our triangle looks something like, let's say those two angles are congruent. Then we know the sides that are opposite those two angles are congruent. So that would be this side and that side. And that's the converse. That's just the flip. Converse means the flip, the reverse, or saying it backwards, you might say. If the angles are congruent, then those two sides are congruent. And then we have the corollaries that have something to do with this, since every equilateral is really an isosceles. And it says if a triangle is equilateral, all sides are congruent, then it is equiangular, all angles are congruent. And it also says the reverse, all in one corollary. If a triangle is equiangular, then it is equilateral. So if you have an equilateral triangle marked all three sides congruent, then you know that the angles must be congruent. And since I know the total is 180, 180 divided by 3 will give me 60-degree angles. And it also says the reverse. If the three angles are all the same, or marked the same measure, then we know it is equilateral, or all three sides are congruent. And that we refer to as the corollary, the base angle theorem. So let's practice this a little bit. Let's see, I'll take my favorite. If AE is congruent to DE, so AE is right here and DE is right here. So we're looking at this big triangle, ignoring these lines inside. AED is the triangle we're looking at. Which angles are going to be congruent? Well, let's see. When I'm looking at the big triangle, opposite ED, I have angle A, and opposite AE, I have angle D. So angle A has to be congruent to angle D. Okay, and now when I look at, let's get my eraser out here so I can take off my markings. Now when I look at angle EDC, let's see, EDC, okay, that's this angle. If it's congruent to CED, CED over here, so I'm just looking at the triangle here, CDE, they want to know which sides would be congruent. Okay, the opposite to that angle is EC. That's this side, and opposite the angle at E would be CD. Okay, I know that by the base angle theorem. I have an isosceles triangle, so if the two angles are congruent, I know I have two sides congruent. Okay, let's go on to the next one. C, if AB is congruent to EB, AB's right here, and EB's right here. Okay, if those two are congruent, so we're looking at this triangle ABE, they want to know which angles are congruent. So opposite AB, I have an angle that's at E, vertex at E, right in here. And opposite BE, I have this angle that's at A. So angle A, and I don't want to say angle E, because look at how many angles there are at E. Actually 4, 1, 2, 3, and then the large one. So I want to name it with 3 letters, AEB or BEA. Okay, and on to D. If EBC, let's see, we'll erase. If EBC, okay, that's this angle right here, is congruent to ECB right here, we're looking at this triangle BCE, then they want to know which sides are congruent. So the sides opposite the angles would be side BE and side EC. Okay, using the base angle theorem, I can get a lot more information from a triangle. So let's practice a little bit here. We've got 50 degrees here. We have an isosceles triangle. 180 minus 50 leaves me with 130. Since these angles are going to be congruent, because I have two sides congruent, I'm going to take my leftovers, 130, divide it by 2, and I find that x equals 65 degrees. Knowing that x is 65, and I have a linear pair right here, x in this angle in the other triangle, 180 minus 65, 180 minus 65 gives me 115. So this angle right here is 115. And I also have an isosceles triangle over here, but my vertex angle is 115, so I have to find the measure of my two base angles. So 180 minus 115 is 65. That's what I have left over because 115 is already here, so 65 has to be split between these two angles. So 65 divided by 2 tells me that y equals 32.5 degrees. Okay, on our next one, B, I see I have an equilateral triangle. So I know all the angles are 60s. I have 120 over here because these two are a linear pair. They must add to 180. And then I have an isosceles triangle. So both of these angles would equal the same amount. So since I have 120 here, 180 minus 120 for my isosceles triangle, I only have 60. And I have two angles that are the same measure, so I'll take that 60, divide by 2, and y equals 30 degrees. Now on C, I'm going to find x, y, and z. So first I eyeball this triangle here, and I say, it's an isosceles triangle. I see two sides are congruent, so my angles are congruent. These two base angles must be congruent, so x has to equal 72. So I already have 72, let's say here, and 72 here, so the leftovers would be y, my vertex angle. So 180 minus 72 plus 72 will equal angle y, or 180 minus 144 equals y, so y equals, let's see, 36 degrees. Now to find z, I know the two sides are congruent. They're even marked congruent, so I knew it was an isosceles triangle, so I can set them equal to each other. 3z plus 2 equals 8z minus 33. Subtract 3z from both sides, and I have 2 equals 5z minus 33. Add 33 to both sides, and 35 equals 5z. Dividing by 5, z equals 7. Now, working on D over here, I see I have an isosceles triangle, so I know this angle at 75 degrees and the angle marked 5x must be equal. So 5x equals 75. Dividing both sides by 5, I find out x equals 15. Now, since I have 75 here and 75 here, my vertex angle is the leftovers. So 180 minus 75 plus 75 is going to equal 3y, my vertex angle. So 180 minus 150 equals 3y, or 30 equals 3y. Dividing by 3, y equals 10. Give you a moment to catch up there. Okay, let's go on to the next few problems. Now, the triangle sum theorem is something that you already know about, because everybody, when we started on Monday and Tuesday, already told me they knew the triangle sum theorem, that the three angles would add to 180. So that helps us find a missing angle. If we have two angles, we can always find the third angle, knowing the triangle sum theorem. Okay, so let's use the triangle sum theorem. Let's see, we have 35 and 65, and we want to find angle 1. So our total is 180, and from that we want to subtract the sum of the other two angles. So we have 180 subtracting, and 35 plus 65 is 100. So we find that angle 1 equals 80 degrees. Now let's look at B. We're looking for angle Z right here. We already have 53, and this angle right here marked with the box tells us it equals 90 degrees. It is a right angle, therefore it is 90 degrees. So in order to find Z, we want to subtract the sum of the other two angles. So 180 minus 53 plus 90 will give us angle Z. So 180 and 53 plus 90 is 143 equals angle Z. So 180 minus 143 must be 37 degrees. Now let's move on to C. We're going to solve for X, Y, and Z. X will be easy because X is in the triangle that has angles 39 and 65. So we want to subtract from 180 the sum of 65 plus 39 to get angle X. So let's add, let's see, 65 plus 39, that must be 104. That will give us angle X. So 76 degrees equals angle X. Since X and Y are a linear pair, I can easily solve for Y just by taking 180 minus 76. That will equal angle Y, because these two have to add to 180. So we have Y equals 104 degrees. So now on the triangle on the right, I already have Y, it's 104, and I have 21, so now I can find Z. 180 minus the sum of 104 plus 21 will give us angle Z. So we have 180 minus 125 equals angle Z, and 180 minus 125 is 55 degrees. Okay, let's move on to example 4. Almost halfway down the page here. We're going to find the value of X and then the measure of angle B. So we have a 90-degree angle, so it's a right triangle, and the two acute angles are X and 2X. Okay, so let's think about that. We know our sum is 180, and it should equal 90 plus x plus the 2x. So when I simplify or combine like terms, I have 90 plus 1x plus 2x is 3x. Subtracting 90 from both sides of my equation, I have 90 equals 3x. Dividing both sides by 3, x equals 30. Oh, so the smaller angle is 30 degrees, and angle B is 2 times 30, or 60 degrees. Now let's look at the measure of one acute angle, example 5, of a right triangle is 5 times the measure of the other acute angle. Find the measure of each acute angle. Let's draw a picture. Okay, I'm going to draw a big, long hypotenuse. It's probably not even long enough. I'm going to label this smaller angle x and my larger angle 5x. Could have dragged that out even further to make this even a little bit more to scale than what it is. So that's what they're saying. We've got one angle and the other one is 5 times the other angle. So I wrote 5x. So what do I know? I know that the sum of these angles, 180, is the 90-degree angle, the right angle, plus x plus the 5x. So when I combine like terms, I have 90 plus 1x plus 5x is 6x. Subtract 90 from both sides, and I get 90 equals 6x. And dividing both sides by 6, I find out x equals, let's see, 90 divided by 6, lost my place here, 15. Oh, if x equals 15, this angle is 15, and this angle is 5 times 15, okay, which is 75 degrees. Okay, we're on to example 6. This time we don't have a picture, we don't have exact measurements, but they do give us an idea of angle A, B, and C inside the triangle. The one thing I know for sure is triangle sum. These 3 angles will add to 180 degrees. So let's see what happens when we add them all together. I could add straight down because they're already stacked, or I could write them across again. 6x plus 11 plus 3x plus 2 plus 5x minus 1, all equal 180 degrees. So combining like terms, I take my 6x plus my 3x plus my 5x, and I get 14x. My plane numbers, 11 and 2 is 13, minus 1 is 12, equals 180. Simplified right off the bat. If I had added straight down, I would have gotten 14x, 11 plus 2 is 13, minus 1 is 12. Okay? Just because they were already stacked, I might have done it that way. Okay, let's subtract 12 from both sides, and we get 14x equals 168. Dividing both sides by 14, 14 goes into 16 once, subtract and I get 2, bring down the 8, and 14 goes into 28 twice. So now in order to find each angle, I know what x is, so angle A equals 6 times 12 plus 11. Okay, all I did was copy this down. Instead of the x, I inserted my 12 that I now know. 6 times 12 is 72 plus 11 equals 83 degrees. Let's solve for angle B. It equals 3 times 12 plus 2, oops, got to put a parentheses there, and here it is, 3x plus 2, or 36 plus 2, excuse me, equals 38. Okay, let's look at C now. Let's solve for angle C. 5 times 12 minus 1. 5 times 12 is 60, minus 1 equals 59 degrees. Now in this case, I might want to check my figuring because I had 3 opportunities to fail here or make a little mistake. So I'm going to take my three angles and just check and make sure that they add up to what they're supposed to add to. So 8 and 9 is 17, plus 3 is 20, 2 and 8 is 10, plus another 8, 180. Checks out. So I have my answer. I have all three of those angles figured out. Okay, let's do a little more practice on the next page. We're going to use this diagram and we're going to do these four problems. If AE is congruent to CE, okay, A to E and C to E. These would be the two angles that would be congruent. Let's carefully name the two angles. EAC, have to use three letters here, and this angle right here is ECA. Okay, and that's we're going to call the base angle theorem. That's how you can abbreviate that one. Base angle symbol TH. Okay, let's look at the next one. We've already got one done. I'm going to erase so we don't get mixed up there. If DAE, let's see, DAE, that's this one, going to put a blue dot there, is congruent to DEA, this blue dot. So we're looking at this little triangle here, DAE. Which sides are congruent? DA and DE. DA and DE. Again, we can call that the base angle theorem. Okay, moving on to the third one. Let's go green. If BDF is congruent to DBF, which is congruent to BFD, then what three sides will be congruent? So let's mark it. BDF is this angle, and DBF is this angle up here at the top, and BFD would be this angle over here. We're looking at the triangle DBF. So what are the three sides that are congruent? If it's equiangular, then it is, we'll call it the base angle corollary. If it's equiangular, then the sides are congruent. So BD is congruent to BF, which is congruent to DF. Okay, if all three angles are congruent in a triangle, all three sides are congruent. Okay, our last one. If AB, there's side AB, is congruent to side BC, which is congruent to AC, we're looking at the big triangle ABC, then I know angle B is congruent to angle BCA, I better use three letters, which is congruent to angle CAB. And again, that's the corollary to the base angle theorem. If three sides of a triangle are congruent, then all three angles are congruent. If the triangle is equilateral, then it's equiangular, in other words. Okay, let's find the unknown measure. Wow, I see three angles that are congruent. So the three sides are congruent. That side that's missing that they want to know about must be 6. This triangle looks to me like an isosceles triangle because it's marked with two sides congruent. Therefore, the base angles must be congruent, and this angle is 70 degrees, just like that base angle. And here we have an isosceles triangle because the base angles are congruent. Therefore, the sides opposite them are congruent, and this side must be 18. Number 8, let's see, we have an equiangular triangle because it is equilateral. I see all the sides are the same, so that means each angle is 5x. Well, let's see, if it's equiangular, each angle is 60, so 5x equals 60, so x equals 12 when I divide both sides by 5. On number 9, we have a triangle that is isosceles. Since we have two angles congruent, I do know that the sides opposite those angles must be congruent. So 4x plus 3 equals 15. Subtracting 3 from both sides, 4x equals 12. Dividing both sides by 4, x equals 3. On number 10, we also have an isosceles triangle because I can see that I have two angles that are congruent, so I know that the two sides opposite those angles must be congruent. We're going to ignore that 20 because remember that's a base, that's not a leg. The two legs are congruent. So 9x minus 8 equals 28. Add 8 to both sides and 9x equals 36. Divide both sides by 9 and we find that x equals 4. Okay, now it's your turn to practice. And let's see, we're going to do pages 3 and 4, which we will be checking next time I see you in your homework packet. Pages 3 and 4. Have a good weekend, everyone.